In this video, we are going to break down this ordinary differential equation, which is among the exact family. So let's dive in. Let's start by proving if it's exact or if it's not. So the way we prove this ordinary differential equation, if it's exact or not, we just have to use this simple technique. Cos x plus y dx. Whatever our dx is, this is our m. This is our function m of x, which is cos x plus y. Wherever our dy is, this whole thing is our n y, function of y, which is 3y squared plus 2y plus cos x plus y. Now, how we prove if this equation is exact? We'll differentiate this function of x with respect to y and differentiate this function of y with respect to x. If the answers we are going to get are going to be equal to each other, they're going to be equivalent to each other, then it will prove that this ordinary differential equation is exact. So let's start. We are taking mx and we are partially differentiating it with respect to y. So the x function, we are differentiating it partially with respect to y. When we differentiate cos x, we are going to get negative sin x plus y. The angle is maintained. But now, we are being told also, for trigonometric function, when you differentiate the function, you also differentiate the angle. We are differentiating the inside angle with respect to what? To y. When you differentiate x with respect to y, it's 0. It's more like we are differentiating a constant. When we are differentiating y with respect to y, it's going to be 1. So 1 multiplied by this is not going to affect this. So we are done for this. Let's come for the function of y. If the function of y is going to be exactly equal to negative sin x plus y, then this equation will be proved to be exact. So we'll get the function of y and y, we'll differentiate it partially with respect to x now. So when we differentiate 3y squared with respect to x, we're going to get a 0. When we differentiate 2y with respect to x, we're going to get a 0. The same for this. Now, when we differentiate cos x y with respect to y, we're going to get negative sin x plus y. Now, we also have to differentiate the angle inside with respect to x. Now, differentiate this guy with respect to x. X differentiated with respect to x is 1, y is 0. 1 multiplied by this thing, it's the same. It still be the same. Now, observe this and this. Are they the same or not? Are they equal to each other? Yes, they are equal to each other. Now, this has proved that this equation is exact. Now, let's solve it. Since we have proved that it is exact, let's solve this. The way we can solve this, it's either you are going to pick the function of x, mx, or the function of y, ny. So for me, I will go with mx. Why? I'm seeing it's a lesser complicated function as compared to this. So I'll get the smaller one. So I'll get mx. Mx is equal to cos x plus y. Now, what is the first step? The first step is to integrate mx. When we integrate mx, which is cos x plus y with respect to dx. With respect to dx. Now, what is the integral of cos? Of course, it is sine. x plus y. Now, instead of adding a plus c, we're going to add a plus fy. Since we are differentiating the function of mx, which is the function of x, we're not going to add fx, but we're going to add fy. So this will be plus fy, the function of y. It will come in handy. You'll see why we usually do this. Now, after the results you have gotten, you have to differentiate them partially with respect to the function which you have added, fy. So we'll differentiate this with respect to y. We'll also differentiate this with respect to y. We are partially differentiating. When we differentiate this partially with respect to y, we are going to get cos x plus y. Then for this one, we are going to get y prime. Now, our answer which we have found after differentiating partially with respect to y, which is of the function which we have added, we are going to equate this whole thing which we have found here to that function which we didn't pick at the first, which was what? Ny. So this whole thing is equivalent to ny. Now, let's rewrite it now with substituting what ny is, which is 3y squared plus 2y plus cos xy. So we're going to say cos x plus y plus y prime equal to, what is ny? 3y squared plus 2y plus cos x plus y. Now observe what we have found. This guy is equal to this guy. Now you can see that this term and this term, they are pairing both, and they are both positives. So meaning when this is added, is subtracted both sides, these two terms, both of them would disappear. So this term can cancel with this term. But if you see this as no term, it is cancelling with this side. The same for this. So we're going to write our result, which we have f prime y is equal to 3y squared plus 2y. Now, since we are seeing we are having f prime y, what we need to find is fy. So how can we find fy? We can just come and integrate both sides. When we integrate this side, we are going to get fy. Now, for these two guys, we can integrate them what? Individually. We can integrate them individually. When you integrate 3y squared, when 2 plus 1 divided by 2 plus 1, it will be 3. So the 3 at the bottom will cancel with this 3. So we are going to have just y cubed. What I'm saying is 3y 2 plus 1 divided by 2 plus 1, which is the same as y cubed. So fy is equals to y, it's equals to y cubed plus, when we integrate 2y, it's the same as adding 1 plus 1 divided by 1 plus 1. At the bottom, we are going to have a 2, which will cancel with this. So this is just going to be y squared. Now, since we have found fy, we are going to go back to our first step. When we integrated this function, we got sine x plus y plus f of y. Then we partially differentiated it with respect to y. Now, why were we doing this? The reason we were doing this is because we wanted to find f of y. Now, since we have found f of y, we're going to get this function plus what f of y is. That is our answer. So our final answer is going to be sine x plus y, then plus y cubed plus y squared plus c. This is our final answer for this question. Thank you for watching, and if you haven't yet subscribed to the channel, you can kindly hit that subscribe button so that you don't miss out on future videos.